Good morning, everybody. Welcome to Technology. We are going to be doing a couple of lessons before we go back to school, just to keep you up to track to where we are and things that are happening. I'd like to draw your attention to the following fact. I've divided the entire term into 5 major sections. So if you just take a look over here, you'll see. I don't want you to stress. It's all been divided quite nicely. I'll make it a little bit bigger there. Today we're going to do hydraulic and pneumatic systems and Pascal's law. And then we go on to pulleys and levers next week. The different kind of disc brakes and systems. And we end off with gear systems. It's all theory with a couple of formulas and sums, but there are no experiments this term. It will all be done as theory. And please, don't neglect term 1's work because that is going to be important for June. All right. Right, great. Great to have you back here. So let us begin. Our first system is going to be mechanical systems. Now we have 2 different types, pneumatic and hydraulic. Pneumatic coming from the pneuma, or meaning air, and hydraulic meaning liquids, for example, oil and water. So in your books, you could put down some nice notes. You could do pneumatic systems and hydraulic systems, and we're going to compare the 2 within a system. Now, in technology, you're quite well aware that our systems, we have an input or a master, we have a process or a mechanism, and we have an output or a slave. And we're hoping that our input will be resulting in a greater mechanically advantaged output. How does this happen? Well, we're going to see a little bit later. So let us begin with pneumatic systems. Pneumatic systems, we have an input or a master, and here's the system, and we have an output. Advantages of these systems are that air system can be compressed and stored as potential energy for later. It's very powerful. We have pneumatic drills that are used for the system. It's fairly cheap and very useful. The downside of pneumatic systems, which you can put in your notes as you go along with yourselves, is that they have kickbacks and they're not very predictable. Then we're moving on to hydraulic systems. Now these are very powerful and they are used with oil and liquids. Now look at this poor guy pumping water out of his leg. Amazing, eh? Amazing guy. Anyway, hydraulic systems, you can also have advantages and disadvantages because they're used with mostly oil, which doesn't freeze easily, a lot of movement, lubricant, and water, which moves from one system to another. Keep in mind, air is compressible, so it's compressed as a potential energy which can be released. For example, when I pump air into this pump, I get an output. Hydraulic systems, however, are used with liquids which cannot be compressed. They're incompressible, which is great because if you push liquid on the side, it comes out that side. Okay. The advantage is that they are very powerful. They can be used with machinery, with engines, with electric motors, but they are expensive and messy, but highly powerful. Let me see. I wonder if a hydraulic press is able to compress a colander. Let's have a look.
Oh. Really interesting.
Check the air car, the liquid coming out of there. Oh yes, not that funny again. Anyway, so how is this happen? How do we put in a system and get such an incredible output? Does anybody know? I can't hear you guys. Anyway, I'll explain it to you. It's all to do with a brilliant man by the name of Pascal. Fortunately for you, you don't have to do all these experiments, just read through them. Now, Pascal came up with a formula, and he says in a hydraulic system, which is a liquid system, in a hydraulic system, no energy is lost, and when you put in an input, it will be transferred equally into the system. So the whole system will have equal pressure. Now that's amazing. Equal pressure, but if we have a smaller area, we can produce a greater force over a bigger area. Now, how the heck will we do that? I'd like you to learn Pascal's formula, and I'd like you to look at this little experiment over here, which I'm going to draw for you so that you can follow. So please follow in your books. Let's make this a little bit bigger again. Bye. Hello, here I am. Right, so we take this piece of paper here. Right. What is Pascal's law? His law is that force equals pressure divided by area. He's got a triangle. This triangle says force is equal to pressure times area. Now that also means that the pressure, which is always constant, is equal to your force divided by your area. Very important. And also what's important is that your area will now equal your pressure times your divided by your force. Anyway, that's not too serious. So what I'm saying is, he did an experiment where he took a thin cylinder and he pushed liquid into a greater cylinder. Alright, let's say that's 10 meters squared in area, and let's say that one was 1 meter squared in area. Right, now he placed a 10 Newton force downwards. Alright, so what will the pressure equal? It equals the force divided by the area. So your force was 10 newtons divided by your area was 1 square meter. Wow! So the pressure there is 10 newtons per square meter, or 10 pascals. That's the force here, 10. Ooh! Now, what will be the force coming out of here? Well, force is equal to your pressure divided by your area. So let's work out what your force is over here. So your pressure here, we said, is 10 times your area is 10, which equals now 100 newtons coming out of there. You had 10 newtons going in, and you have 100 newtons going out. Now, how the heck does that happen? Well, guys, I like to explain it like this. Small cylinder, big cylinder. The pressure is equal everywhere. The pressure is equal everywhere. But here you have a greater area, so there's more force. Ta-da! Okay, so with that in mind, we can do many sums and we can do many solutions. See, what he was saying was that your area is small here, your area is great here, but you'll have more force because you've got more of the equal pressure pushing up at a bigger area. So what I'd like you to do is I want you to learn Pascal's law. Okay? Learn it off by heart. Learn the formula, which is force equals pressure times area, or pressure equals force divided by area. Write that down for yourselves. Keep that in mind. And then we are going to work out the mechanical advantages. You don't have to do these sums over here. I want to show you something else quickly. Crazy, huh? Great. So, what are you going to do now? You are going to read through the notes from page 48 all the way up until the end of page 63, and I will be pushing on 1 or 2 worksheets for you to do as well. So, I hope you understand. Sum up, hydraulic is to do with liquids, oils, waters. Great pressure, messy, expensive, but very powerful, very immediate, doesn't freeze. Do yourselves notes. Pneumatic, to do with air, okay? Only problem with pneumatics is that they can have kickbacks and danger. So guys, best of luck. I'll get back to you soon.